Hi class, this is a video on Tuesday's material, how to draw particle models using the ratios in a balanced chemical reaction and how to fill in a BCA table given the particle models. So we started off by first talking about how balanced chemical equations are showing the ratios of how things react. So they're just like cooking recipes. So here we have a recipe for making a sandwich. So if we use 2 pieces of bread and 1 piece of cheese, we will always make 1 sandwich. In chemical equations and balanced chemical equations, they're just like the recipe we saw before, except we're using molecules and atoms and different compounds. So here's our making water chemical equation. Okay, so first we have to balance this. So let's just check. Here we have 2 hydrogens. Okay, here we have 2 hydrogens. Okay, we have 2 oxygens over here, but over here we only have 1, so we need to multiply this by 2 to get 2 oxygens now, and that gives us 2 oxygens, but this changes the number of hydrogens because we also multiply the hydrogens times 2, so now we have 4 hydrogens. So over here we need to multiply by 2 to get the 4 hydrogens and put a 2 here. So now we have a balanced reaction. What type of reaction is this? Well, we have one. If we look at the number of products here, we only have 1 product. And as soon as you see just 1 product, we know this is a synthesis reaction. So we've balanced this equation. So now we have the balanced reaction here. So remember, the coefficients are going to tell you, remember, these are the coefficients. These coefficients tell you how the particles react. Just like we had 2 pieces of bread and 1 piece of cheese, right? We've got 2 H2s and we have 1 O2. So this equation means we take 2 hydrogen molecules plus 1 oxygen molecule, and we can make 2 water molecules, 2 H2Os. So let's draw the reactants and the products here. Okay, so for my hydrogen, I'm just using a white circle here. My oxygen is a red circle. So first I need to, when I'm drawing my reactants, first I'll draw what's in the formula. So, and anything that's in the formula is connected together. So there's my hydrogen. Okay, and then I look at the coefficient. Oh, it says I need 2 hydrogens. So let me draw 2 hydrogens here. All right, looks like I need to change colors here. Go to red. All right, and then for my oxygen, there's a 1 in front of here. Okay, and looking at my formula, I have 2 oxygens bonded together. So let me take my oxygens and put those together like that. Okay, so my reactants are 2H2 and 1O2, and that will make 2H2O. So I need to make 2H2O. Okay, liquid. So I'm going to put them down here since they're liquid. Liquids don't float around like gases, so, and I need to make 2 of them. 2 H2O molecules. All right, so those are my reactants and my products. All right, so now once we have this particle model, right, we want to look at some of the ratios in this balanced equation. So for every 2 H2 molecules, how many O2 molecules react? And if we look here, 2 H2 molecules needs 1 O2 molecule. Number 2 says for every 2 H2 molecules, how many H2O molecules are produced if you have plenty of oxygen, plenty of O2. So for every 2 H2, we get 2 H2O molecules. Okay, those are the ratios in the balanced equation. Now, looking at our picture here, okay, we see that we don't have just 2H2 anymore, right? Because in real life, this is the recipe, okay? There's our recipe, 2, 1, 2, but we might have a lot more than 2 hydrogens. We might have 10, 20. In fact, most of the time we'll be working with numbers much, much, much bigger than these. So if you look at the reactants here, right, we don't have 2H2. If we count, we have 1, 2, 3, 4 H2s. Okay, so these coefficients only tell us how the things react. They tell the ratio of how the particles react. But in in our examples, in our problems, we're not going to be always given exactly what the balanced equation says, because that's just the recipe for making the water. So let's use this recipe, and I'm going to show you 2 ways to do this, right? To draw what should be in the products. So one of the ways we can do this is we can find a group of 2 H2s and 1 O2 molecule, right? And we know that that will give us 2 H2O. So if I take 2 H2s, here's 2 H2s, and I circle them with 1 O2, I know that these will react and they will form 2 H2O molecules. So I can draw 2 H2O molecules, right? These transform into those. If I look over here, now I have another group of 2 H2s and 1 O2. That will give me another 2 H2O molecules. Okay, so we have a total of 4 H2O molecules here. Okay, and over here we can see that we have 4 H2 molecules, and we have 2 O2 molecules. Okay, so 4 H2 molecules with 2 O2 molecules will give us 4 H2O molecules. And notice the ratio between the H2 and the H2O is the same. The ratio between 4 H2 to 2 O2, that's still 2 to 1, right? It's still a 2 to 1 ratio. It's just doubled. It's now 4 to 2, right? If we took our 2 times 2, we'd get 4. 1 times 2, we get 2. Here, 2 times 2, we get 4. All right, that's getting a little messy, but hopefully you get the idea there. All right, in this case, we've got 6, 1, 2, 3, 4, 5, 6 H2. So I'm going to write that under here. I'm going to show you a different way of doing these particle models without grouping, instead of grouping like we did before. Now I count here 1, 2, 3 O2 molecules. 3 O2 molecules. All right, and we got to draw our products, our H2O molecules, and figure out how many of them we should have over here based on the recipe. So if we look here, how do we get from, right, 2 to 1 is the same ratio as 6 to 3, but how do we get from 2 to 6 here? Well, we multiplied this by 3 to get 6, right? And we multiplied this 1 times 3 to get 3. And so we're multiplying our coefficients by 3 to get the number of reactants here. So we do the same thing for our products. 2 times 3, that'll give us 6 H2O molecules. So in our picture here, we need to draw 6 H2O molecules. And I guess I really should be drawing them as water, as liquid, not doing a good job of keeping my states of matter straight. Okay. 1, 2, 3, 4, 5. We need 6. Okay, so we have 6 H2O molecules here. Okay, because we are tripling the amounts in each of these. All right, new reaction. Now we're going to make ammonia. So remember again, the coefficients are going to tell you the ratio of how the particles react, of how the substances react. Okay, so first let's look at the ratios. What's the ratio of H2 to N2? Okay, well, our coefficients give us all that information. So the ratio of H2 to N2 is going to be 3 to 1. Those little dots in math, that means 3 to 1 ratio. That shows a ratio or a proportion. What's the ratio of H2 to NH3? Well, that ratio would be 3 to 2. N2 to NH3, that's 1 to 2, okay? So those are our ratios. So looking here, I'm going to count my particles. First, I'm going to find my H2. I see that this represents H, so I have 1, 2, 3, 4, 5, 6. Okay, so I have 6 H2 molecules plus I have 1, 2, N2 molecules. Okay, so you can do the thing where you look at, okay, what did we multiply this recipe by? Oh, it looks like I multiplied by 2 to get it, so I should multiply this by 2 to figure out how much I need in the products. Okay, so 2 times 2 gives me 4 NH3 molecules. Okay, the other way you could do it is, okay, I know I need to use 3 H2s and 1 N2 to make 2 NH3s. I'm going to group those together. Here's a group of 3 H2s and 1 N2. That's going to give me 2 NH3s. Oh, we got to change to blue here. Change to blue. So I'll make 2 NH3s for that group of 1 recipe. Okay, and over here I can see I have another group of 3 H2s and 1 N2, so that will give me another 2 NH3s. Apologize for my messy molecules here. Okay, let's get another example. Okay, so again here, let's look at this example. Oh, this looks like exactly the same example as before, so I don't think that we need to do that, because looking back, looks like we did it already. Okay, new reaction. Here's our methane combustion reaction. Again, we're going to draw the products based on the reactants. Okay, so looking here, I've got 1, 2, 3, 4 CH4s. These are the CH4 molecules. 1 carbon, 4 hydrogen. So I'm going to write down here I have 4 CH4 molecules. How many O2s do I have? 1, 2, 3, 4, 5, 6, 7, 8. 8 O2 molecules. Okay, well, now this time we have 2 products to draw. Okay, but that's okay. That's nothing we can't handle. Okay, so if I look here, my coefficients, 1, 2, 1, 2. And so I can see that what I'm doing here is I'm multiplying these coefficients by 4. Okay, so what I need to do is multiply each of these coefficients by 4 to get the correct number of molecules in my products. So here I should have 4 CO2 molecules. And here I should have 8 H2O molecules. Okay, so now I got to use the correct colors and draw those in. Remember, the colors do correspond to things, so we need to have the correct colors in there. So CO2, I'm going to put my 4 CO2 molecules. So let me make the 4 carbons first, and then I'll add the oxygens. Let's put one over here. Okay, so let me add 2 oxygens to each of those carbons to make CO2. If you recall, CO2 is linear. Okay, so that's my 4 CO2, and now I need 8 H2O. So I'm going to make 8 H2O gas molecules. Everything's a gas. Nice. Try to make these a little neater. Of course, the gas should be kind of spread out randomly throughout the box. 1, 2, 3, 4, 5, 6. Here we have number 7. And here we have number 8. Remember, water is bent. All right, so there's our particle model of the products. All right, so now let's introduce the BCA table. So once we've drawn the reactants and the products, there's another way to represent the chemical reaction, and that's by doing something called a BCA table. So there are some steps to filling in this BCA table. So I'll go through it with you. So the first step is to look at the reactants. The reactants represent the before line, the B in BCA. So all you do is first on the top, you have the reaction. Okay, remember these are going to the products. And you just count up, okay, how many H2s do I have? I have 1, 2, 3, 4, 5, 6, and I write down the number here. How many oxygens do I have? Well, I have 1, 2, 3, and I put the number here. All right. And in the before line, that's before, do we have any H2O? No. So that's 0. Okay. No H2O in the reactants. Okay, so that stays as 0. And so that's our before line. That's what goes in before. These are the reactants. All right, then step 2 is to fill in the after line. Okay, this represents the after. And this is the products are after the reaction. So after the reaction, if we count here, we have 0 H2. We have 0 O2. There's no H2 or O2, but we have 6 water molecules. Okay. And then step 3 is to fill in the C line. This C stands for change. What changed during the reaction? And so if we have the B and the A, we can see how the molecules change. And so if we start with 6, in order to get to 0 after, we have to subtract off 6. So 6 minus 6 gives us 0. Okay. If we have 3 O2s, okay, then we have to subtract off 3 O2 molecules, okay, in order to get 0 here. If we start out with 0 H2Os, then we need to add 6 H2O molecules to end up with 6 over here. So this change line is just using what was there before and what is there after to figure out what the change is. Now notice something interesting. See this change right here? This is the same ratio, okay, as in the balanced equation. 2, 1, 2 is the same ratio as 6, 3, 6, right? 6, 3, 6 is just taking this ratio and multiplying by 3. And we're getting that ratio in there. It's just a tripling of the coefficients in the change. And then the sign, okay, the sign is important. The sign shows us whether molecules are being reacted away or if they're being produced. If the sign is negative, that means we're losing those molecules. We're getting rid of those molecules. We're reacting those molecules away. So the H2 and the O2 are reacting away. And the positive means that we are producing water in this case. All right, so let's try this for a reaction. Here's a new reaction. So first, remember our before line, the reactants are the before, the B. The products are the after line. So pause the video and try it yourself first and then check it with what I do. Okay, let's see here. So if I go here and I say, okay, what's my before line? Well, I'm going to put in my NOs here. 1, 2, 3, 4. 4 NOs. How many oxygens? 2. How many NO2s? Well, 0. Okay, let me look at my after now. Well, how many NOs do I have here? 0. Okay. How many O2s do I have? 0. How many NOs? I have 4. All right, let's figure out my change line. How do I go from 4 to 0? Well, I must have gotten rid of all 4 NO molecules. How do I go from 2 to 0? I must have subtracted away all of the O2 molecules. How do I get to NO2? I needed to produce 4 NO2 molecules. And we've finished filling out the BCA table. Okay, I hope this video was helpful, and the next part after that is to think about what if, think about whether you always have to have 0 reactants like here. See how everything, the reactants are 0 and 0? Do you always have to have 0 and 0 there? And think about this situation where we're doing the water reaction and think about what might happen and not whether you could have something that's not 0.